In this video, I'll be discussing how to read and write drive parameters using a Modbus master device, such as a PLC or HMI. The topics I'll cover are Modbus communication basics, Modbus addressing modes, how to assign a Modbus address to a drive parameter, and some Modbus addressing examples for both standard and modified mode. So if you're ready, let's get started. The Modbus communication protocol provides both Modbus RTU for serial RS-485 based communications and also Modbus TCP/IP for Ethernet communications. Control Techniques general purpose drives, such as our Commander C200, along with our high-performance drives, such as our Digitex HD, can both be accessed using either serial or Ethernet Modbus communications. Additional communication adapters may be required for Modbus communication. For general-purpose drives, you'll require a model number AI-485 adapter to perform serial RS-485 Modbus communications using Modbus RTU. General-purpose drives, frame sizes 2 and larger, have an expansion slot that can accommodate a SI Ethernet module. Adding this module to a general-purpose drive will enable Modbus TCP/IP communication. The Unidrive M400 will require either the AI-485 adapter or the SI Ethernet module, depending on the type of Modbus communication desired. You may also add a SI Ethernet module to a Unidrive M701 to provide Modbus TCP/IP communication. A Unidrive M700 may also communicate using Modbus RTU by adding a KI-485 adapter. The Modbus protocol was first developed in the 1970s by Modicon for connecting industrial devices, such as drives, to a PLC. Modbus uses a client or master, server, or slave protocol to communicate with field devices. Our drives are Modbus servers. In a Modbus network, there may be only one client or master. Each server or slave in the network must have a unique ID. Data being communicated within a Modbus network takes the form of registers. By definition, Modbus registers are 16 bits in length. However, and depending on the capability of the Modbus client, two contiguous 16-bit registers may be accessed as a single 32-bit register. Our drives support two different Modbus addressing modes: standard mode, which is the default, and modified mode. Modified addressing is required to access drive parameter numbers greater than parameter number 99. For example, if I wish to access menu 3 parameter 118, I would need to change the addressing mode to modified. For Modbus TCP/IP communication, the addressing mode is changed using parameter number 13 in the Modbus setup menu, which is menu 15. In a Digitex HD, you may access this parameter by opening slot 3, menu 15. In a Unidrive M700 or Unidrive M702, this parameter is found in slot 4, menu 15. In a general-purpose drive that is equipped with an SI Ethernet module, the addressing mode parameter is found in slot 1, menu 15, parameter 13. The addressing mode may also be changed when using Modbus RTU. To do that, refer to menu 11, parameter 24. The settings that include an M in them, such as values 4 through 7, 10, and 11, are what you would choose to change the mode from standard to modified addressing mode. The actual value you choose to use will depend upon the serial communication requirements for your PLC or HMI. After changing the mode, you must reset serial communications by turning on Menu 11, parameter number 20. This parameter will turn off by itself once it's turned on.
A Modbus client communicates to servers in the network by transmitting what is called a Modbus ADU, or Application Data Unit. The Modbus ADU can be thought of as the envelope that contains the Modbus message. The Modbus ADU consists of two parts: the Modbus Application Protocol, or MBAP header, and the Modbus Protocol Data Unit, or PDU. The Modbus MBAP header contains a unit identifier. The unit identifier is used to identify whether the destination node is the host drive or an option module. Ordinarily, when using Modbus TCP/IP, a drive is identified by its IP address alone. However, you must ensure that your Modbus client supports the ability to include the unit identifier as part of its message. Valid unit identifiers are shown in this table. A Modbus function code is included in the client's message. It is used to signify the type of data that the client is requesting from a server. Function codes that may be used with R drives are shown in this table. As shown on the previous slide, the function codes that are supported by R drives all pertain to Modbus holding registers. According to the Modbus protocol, holding register addresses must fall within the range from 40,001 to 49,999. The type of client device or master that you're using will determine whether a Modbus address contains either 5 or 6 digits. Modern Modbus clients can accommodate 6-digit addressing. Using a modern client, holding register addresses may range from 400,001 to 499,999. Drive parameters may be either 1, 8, 16, or 32 bits long. Further, some parameters are read and write, while others are read-only. To determine the data type for a parameter you'd like to access using Modbus and its read-write status, refer to the Help tab in Connect Software as shown here. This is Menu 1, Parameter 21. Referring to the Help, the first thing you'll notice is its type. This particular parameter is 32 bits long. In the coding field, you'll see the abbreviation RW. That means that this parameter is read and write. On the other hand, Menu 7, Parameter 1 is 16 bits in length, and it is a read-only variable as designated by the RO in the coding field. To assign a Modbus address to a 16-bit drive parameter, use these formulas. There's an asterisk next to the -1, and that is due to the fact that some Modbus clients or masters automatically subtract 1 from the register address. If you're not getting the data that you expect, simply add 1 to your address and try again. Here are some examples of some drive parameters and their Modbus addresses. Again, if you do not get the data that you expect, simply add 1 to your address and try again. 32-bit drive parameters require 2 consecutive 16-bit registers. The formula that is used to calculate the starting address for a 32-bit parameter is shown here. Notice that there's an offset of 16,384 that must be added to the starting register address when addressing 32-bit parameters. Here are some examples of 32-bit register addresses. Modified mode is used to address parameter numbers greater than parameter number 99. To use modified mode, you must set parameter number 13 and menu number 15 of your Ethernet interface to modified. In my example, I'm using a Digitax HD. Therefore, modified mode can be changed by entering slot number 3, menu 15, parameter 13. If you're using a Unidrive M700, it is slot 4, menu 15, parameter 13. If you're using an SI Ethernet module, it would be slot 1, 2, or 3, depending upon where the SI Ethernet module is installed.
Control Techniques drives do not utilize floating point math. All math performed inside the drive is integer-based. When modifying parameters that require decimal places, like menu 1, parameter 21, which is shown here, you must multiply your desired value by either 10, 100, or 1000 to accommodate the implied decimal places. For example, if I wish to set the preset speed to 100, I would send the number 1000, which will result in the value of 100.0 as my preset speed.
Thank you for watching this video, and as always, thank you for choosing Control Techniques.